This is the video for slope and Y-intercept. Every line has a slope and every line also has a Y-intercept. Starting with the slope of the line is going to be the difference between two y values over the difference between two x values. This is the same thing as the rise, that's the change in y, over the change in x, which is also the run. The slope tells us how steep a line is. The y-intercept of a line, this tells us where the line touches the y-axis. You can also think of this as being the y value when x is 0. You can also think of the y-intercept as being like the starting point. Let's look at this first graph. Let's first find the slope. To find the slope, I'm going to look along this line, and I want to find at least 2 points where this red line intersects at whole numbers. So it's 2 points where the line is hitting the exact corners of a grid box. So one point that works is right here. That's at the exact corner of a grid box. Another point that works is here. And then there's another point down and to the right here. Right? All of those points are the exact corners of a grid box. Now that I have those points, I'm going to draw a slope triangle. So it's a right triangle that goes in between those 2 points. So I can draw one there, and I can also draw one right here. Now I can use either of these triangles to find the change in y, which is the rise, and the change in x, which is the run. For the rise, that's how high or how low the line is going for each of these triangles. So that's these blue lines that I just marked. And then I can count how many units it is. So it goes 1, 2, 3, 4 units. So 4. Same thing here. 1, 2, 3, 4. 4 units. So my rise is 4. The change in y is 4. For the run, that's looking from left to right, how far that goes. That's what I'm marking in orange right now. So I'll count the units by counting the squares. 1, 2, 3. So my run is 3. 1, 2, 3. My run is 3. So my slope is 4/3, or 4 over 3. The last thing I need to check with my slope is if it's positive or negative. The way that I can do that is if I imagine that there's a person, a little person, standing on the left side of this line. Right, I just drew that person in. And that person is going to walk to the right. If that person walks uphill, it's a positive slope. If that person walks downhill, it's going to be a negative slope. So I'll even write that in my notes here for slope. If a line is going up, it's a positive slope. If a line is going downhill like this, that's a negative slope. In this instance, this person, if they walk from left to right along this line, they're going to walk downhill. So I need a negative slope. So let's add that in. Our slope needs to be negative. Now I have my slope, negative 4 over 3. The y-intercept is where the line touches the y-axis. The y-axis is this vertical line right in the middle of our graph. The red line touches that y-axis right here. that y value right there, I'm going to label this. This is the y-intercept. That y value is -1, so my y-intercept is -1. Let's look at the next graph. To find the slope, let's look along this line, and I need to mark at least 2 points where the line intersects at whole numbers, or where it hits the exact corners of a grid box. So this point that I just marked works, so does this point, so does this point, so does this point, right? Any of these points work. Then I'm going to draw in slope triangles to help me see. I can draw any one of these to help me see the slope and the rise and the run. Here's my rise. Now, it's very tempting to look at this triangle and look at the rise and see, okay, well, it's going 1 unit up like that, so my rise is 1. However, whenever you're doing slope, you have to look carefully at the x and y axis. Let's look at the y axis. It goes from 0, then it goes up 2 squares, and then it's at 20, and then goes up 2 squares again, and then it's at 40. So that means every square, it's actually going up by 10. So going back to my slope triangle, if the rise is going up 1 square, the change in y is actually 10, because the y-axis is going up by 10 each time. So my rise is 10 over, let's check the run. That's how much the triangle is going from left to right. It's 2 squares, but let's check the x-axis. The x-axis, it starts at 0, 2 squares later, it's at 1. Another 2 squares later, it's at 2, and so on. So that means if my run is going to the right 2 squares, the change in x is actually only 1, because I went from 0 to 1. Same thing here. I went from 2 to 3. Okay, so my run is 1. My slope is 10 over 1. That fraction can be simplified to just 10. Last, let's check if this slope is going to be positive or negative. I'm going to draw a person starting on the left. And imagine that that person's walking to the right. That person will be walking uphill, so this is a positive slope. So since it's a positive slope, I can leave this number exactly as it is. The slope is positive 10. For the y-intercept, that's where this line touches the y-axis. That's right here where I just circled. There's my y-intercept. That y value is 20, so my y-intercept is 20. Let's look at a table. For slope, instead of thinking about this as rise over run, I'm going to think of it as the change between 2 y values over the change between 2 x values. I'm going to write down the formula. It's this y2 minus y1 over x2 minus x1. So y2 minus y1, that's, you pick 2 y values, so I'm going to choose just look at these two, and I'm trying to figure out what's the difference between those two numbers. Now you might be able to see it in your head, right, from -5 to 3, what's that difference? But we can also use subtraction. So I'm going to take the second y value, that's what y2 means, that's this 3. So 3 minus the first y value, that's y1, that's this -5. So 3 minus -5. You can do that in your calculators. 3 minus -5, that equals +8. So that means from -5, if you add 8, that's what gets you to +3. Then you look at the x. You need to figure out the difference between 2 x values. That's this difference right here. Going from 2 to 4, how much is that changing? Now you might be able to see and think in your head, right, from 2 to 4, what's that difference? But let's also use subtraction to double check. x2, that means the second x value. That's this 4. So 4 minus x1. That's the first x value. That was 2. So 4 minus 2. 4 minus 2 is equal to 2. So my slope is 8 over 2. And you can simplify this fraction. 8 over 2 simplifies to 4. So that's our slope, 4, or 8 over 2. The y-intercept, remember that the y-intercept is when x is 0. Well, looking at the table starts at an x of 2, not at an x of 0. So I'm going to have to work backwards to figure that out. Well, notice that the table, my x values, is going up by 2 every time. Right? It's going from 2 to 4, and then from 4 to 6. So then I can just go backwards. So instead of adding 2, if I subtracted 2, that would get me to an x of 0. That's what I want. Then let's look at the pattern for y. The y values is adding 8 every time. Right? It goes from -5 to 3. Then it adds another 8. Right? It goes from 3 to 11. And it adds another 8 to get from 11 to 19. So if I just take that same pattern and go backwards, and instead of adding 8, if I subtract 8, -5 minus 8, I can do that in my calculator, I would get -13. So now I know what the y value is when x is 0. It's -13. That's my y-intercept. So -13.